anti-septic surgery. Applied science has saved many lives. I converted your basic science ideas into something that has benefited humanity far more.
You fool! That was only because of my research on fermentation and bacteria. Your discovery wouldn't have been possible without it.
That may be true, but your discovery didn't revolutionize antiseptic surgical techniques.
Well, I proved that disease was caused by germs and created the first rabies vaccine. So I did save thousands of lives. Was it not my research and discovery on microbes that gave you the tools to do so? What do you think?
To show the beneficial and necessary relationship between basic and applied science, we'll present the narrative of Louis Pasteur's contribution to germ theory and how it helped Lister's research in the beginning of antiseptic surgery. In 1854, French chemist and microbiologist Louis Pasteur was requested to investigate a wine distillery at the University of Lille, where he was a professor and dean of the science faculty. His studies on these issues led him to study fermentation, especially the formation of lactic acid and butyric acid. Pasteur's research on butyric acid fermentation showed that fermentation needed specific organisms. Pasteur discovered that passing oxygen through fermenting liquids might stop the fermentation process, a mechanism known as the Pasteur effect. He deduced this was due to a life form that could only function in the lack of oxygen. To define species that live with or without oxygen, he coined the labels aerobic and anaerobic. He also suggested that anaerobic microorganisms are involved in putrefaction. Pasteur applied his knowledge of germs and fermentation to the French wine and beer industries, sparing them from manufacturing and export contamination concerns. At Napoleon III's request, Pasteur researched wine contamination and found bacteria. Pasteur used a simple method to prevent contamination, heating the wine to 50 to 60 degrees centigrade. Pasteurization kills aging microorganisms, hence it's rarely used for aged wines. However, it is still used on several foods and beverages, such as milk. Due to the traditional belief that life may develop spontaneously, fermentation and putrefaction were often considered spontaneous. John Tuberville Needham and Georges Leclerc Count de Buffon debated this. While both endorsed the theory of spontaneous generation, Lazzaro Spallanzani claimed that life could never spontaneously generate from dead matter. Pasteur approached the issue by conducting an experiment. He sterilized beef broth in a swan neck flask, which has a long bending neck that traps dust and contaminants. However, if the broth was boiled and the flask neck was cut off afterward, when exposed once again to air, it eventually turned hazy, signifying microbial infection. The test showed no spontaneous production because the boiling broth remained sterile after being exposed to air. This not only resolved the philosophical debate, his work became essential to the discovery of antiseptic treatments in wounds. Influenced by Pasteur's work, showing that heat and phenol can kill microorganisms, scientist Joseph Lister derived the concepts that enabled him to introduce the antiseptic principle into surgery. Joseph Lister had been working on the mechanism of coagulation of the blood and role of the blood vessels in the first stages of inflammation. He proposed that sepsis may be caused by a dust that resembles pollen, rejecting the widely held belief that miasma, which is unclean air, causes sepsis. In 1865, Lister learned of Pasteur's work on fermentation and his conclusion that microbes causes disease and fermentation. Lister accepted Pasteur's idea as the truth he'd expected. Initially, he thought only air can transmit germs. Because of this, he tried to create an antiseptic barrier to shield it from the surgeon's hands and tools. He found an antiseptic in carbolic acid, which was used to clean sewers. To prove his method, Lister performed the groundbreaking procedure of wiring a fractured patella for the first time in 1877. It involved purposefully turning a minor fracture, which posed little threat to life, into a compound fracture, which frequently led to widespread illness and death. The media covered and criticized Lister's idea. The effectiveness of his sterile procedure convinced the medical opinion around the world that his method increased surgical safety. His work led to more specialized methods of sanitizing the operating environment, reducing infection and mortality. His principle of preventing bacteria from entering an open wound is still valid today. Thanks to Louis Pasteur's basic science and Joseph Lister's applied science, humanity was able to advance surgical techniques and prevent many deaths.
We must not be divided in science. What do you seek to gain with my answer? Why must one be more important than the other? For if I tell you that applied science is more important, we will lose all the wonders, discoveries hidden in the world around us. Do you think not that the mysteries of the world should not be questioned, that you have nothing to learn from what is untouched by the human hand? No great mind would be so foolish. However, if I told you the reverse, that basic science is more important, you would not build off the discoveries that have the potential to change the world. You would just barely scratch the surface of the universe. Surely you wouldn't be so foolish as to think science stops there.